moment, and his talk, which I will give you the title for now, is Generative AI from Data Analysis to Data Agency. So Professor Aldo Faisal is the professor of AI and neuroscience in the Department of Computing and the Department of Bioengineering here at Imperial. He was awarded a prestigious UKRI Turing AI Fellowship and is the founding director of the UKRI Center for Doctoral Training in AI for Healthcare. And that's sort of, if you're counting these things, kind of north of 20 million pounds worth of funds, which is very exciting. Aldo holds a chair in digital health and design and data science at the University also of Bayreuth and in Germany, and is the director of the Behavioral Analytics Lab at the Data Science Institute, and associate investigator at the MRC London Institute of Medical Sciences, and is affiliated faculty at the Gatsby Computational Neuroscience Unit. So he kind of gets around, and that's ACL. So Aldo, thank you very much for joining us. Will you join me as well?
Thank you, Mark. Thank you, Ken, for organizing this fantastic event. So timely and so right in time. In fact, I have 3 name badges on here because there are 3 events on generative AI going on today. I'm sort of shuttling between them. But maybe I should just explain something about the title. And that has to do really with what is AI? And when I grew up, AI was something that you didn't do because it failed and crashed, and you did machine learning instead. Right? That was the cool thing to do for us. And the point that I want to make is AI is ultimately a question. How do we build systems that solve problems for which humans need intelligence to solve? And the current answer is clearly machine learning. You train a system with data to learn the solution. And that brings us to the slightly old-fashioned title of big data, which is actually 2 things. It's data science, so asking interesting questions of data, and data engineering, which is about how to actually aggregate, make the data available, useful, and even compute on it in a reasonable time, as we just heard from Peter. Another way of phrasing that, what is AI, is, well, AI is actually 2 things. It's talking about data and talking about agency. And about up to January this year, I would always have stressed people, guys, data is a lot more than just data analysis. AI is a lot more than data analysis. It's about data agency. And people are saying, yeah, sure, okay. I think by now we understand that we have systems that have agency because they can interact with us, talk to us, and pass the Turing test. And for my relatively short life of 40 plus years, that's a big deal, right? And the realization is, we've passed the Turing test. It's just blown through the doors, and we need to think about the next question here. So what can AI do? Well, I believe that AI, specifically through the help of machine learning, can learn to do anything a human can do if there is sufficient data to train that AI. Okay? And again, before January, after January, these discussions look very different. January is for me the magical point where people started to use large language models on a, so to speak, leisurely basis. The interesting thing here is that actually the revolution was the revolution of machine learning, of which we're seeing increasing examples. And why is it really a revolution? Well, the point was, when AI started in the 1950s, 1952, it was effectively about logic-based reasoning. We need to bring logic in, we need to bring knowledge into the system, and then it will go through the rules of logic, and the problem is the system cannot recognize a person, cannot understand text, it cannot really achieve anything particularly interesting. And so the original AI community crashed and burned with that, and by the 1980s, AI is something that you wouldn't do and you wouldn't get funded. There was in parallel, almost also started in the 50s, a movement of sort of connectionisms, neural networks, people who came from psychology, cognitive sciences, and statistics and said, well, why don't we build technology that learns the solution instead of people building the solution? And that's really the revolutionary part of that, because for the first time in human history, since we worked out how to make fire, we are not the solution developer anymore. The system learns the solution from data. That's the data-driven approach. And you can try to take it to the extreme, and I try to take it to the extreme. How much can we learn just from the data? But of course, at some point, we will need to reconcile, 400 years of human scientific inquiry and all the theories and experiments that were done before that. and reconcile that with the data-driven approach. But that is really the revolution. We are transforming how we're innovating. And so it shouldn't be surprised that we're now at this space, we had the machine learning revolution coming in with neural networks, support vector machines, Bayesian inference engines, then the rediscovery of neural networks for deep learning because we had scale, because we had data, and we had compute capacity. And then by the 2020, we arrived at the foundation models, to which, of course, also the large language models belong. And that started already in 2017, to be honest, where we actually really seeing the next generation breaking through. And these timelines is sort of how I used to give talks. And then I used to give talks with even higher temporal resolution because the pace is accelerating. Yeah, we had ChatGPT release in November. We heard Google talking about BART. Microsoft went into the Bing craze. Meta AI kicked off. Anthropic, so that, so to speak, split off from OpenAI with some other interesting ideas, started in March. We got GPT-4 in March 14th. Microsoft launched the Copilot, and now we're getting ChatGPT plugins. And that's just in the last 6 months. And then today, we get news happening up. So I'm just trying to keep up with what's happening. So people are using already generative AI to create automatic distribution of attack ads. Literally at the previous workshop just down the road, I was given the new European framework for building excellence and trust in AI. And last night, I don't know if you noticed that, the stock market in the US crashed because a very realistic image of the Pentagon on fire was released, recollecting to 9/11. I mean, that's the pace, and probably these slides are out of date by the end of my talk. Okay, so let's slow down for a moment. So I actually work on a specific type and domain of AI, and that is AI for healthcare. So how can we help people? And maybe the first thing I should always say at this point is, when we're talking about AI for healthcare, we're not talking of replacing doctors and nurses. We're talking about, and I think also my colleague from law said the basically same thing, we're trying to reduce the unmet demand for health and care. If you live in the UK, you're acutely aware of the tremendous pressures the NHS is under. And of course, with the massive staff shortages and the hundreds of thousands of staff that are missing, it's not about taking jobs away. It's about freeing capacity for these people to actually help and treat people and take away a lot of the routine work that maybe does not require that level of attention. So that's why I'm doing AI for healthcare. It's a good thing to do. But the other thing why I do AI for healthcare, because it contains all the elements that make AI a hard problem. You need to do with safety, with trust, with explainability, with human factors. You need to interact with humans. Right? If I wanted to build a factory that runs on its own with no human inside, that's a different type of AI. But if you want to build human-centered AI, then AI for healthcare, it contains all these elements and models. And of course, you need to deal with data, with algorithms and learning. And so, as Mark mentioned, I'm delighted to have been able to be part of this journey that we set up really a pioneering center in AI for healthcare in London, where we can have 86 postgraduate level researchers working on problems of AI of healthcare of all different flavors. And we follow a very strict model of pairing AI researchers and clinical researchers together to advise and forge a new breed or a new type of researcher who moves, effortlessly across the different domains. And one interesting thing about healthcare that's also interesting, it's of course a regulated domain. There are rules on what you can and cannot do. And that makes it very interesting from an AI algorithmic perspective, because once you start to understand the regulations, how ethics, how human interaction is judged, it changes the course of how you start even designing the algorithm at the equational level. And so that makes it a very interesting starting point to thinking about AI for healthcare. And of course, we can then do wonderful things, such as with my colleague Amar Niemer, who is a neurosurgeon, and we've been talking for quite a while about, GPT-4 gets assessments really well. You can pass school exams in the US, you can pass medical license exams, and this is just an overview from a recent paper I found last night about the current performance of GPT-4, which is up here on a whole range of US assessments. Okay, that's quite interesting. They are quite often multiple choice, so very easy to frame. And what Amar then did is he actually looked at exams that are slightly more advanced than advanced placement course. So that's the course that you take for credit in high school, so you can jump a year of classes in college, in American college. So he looked actually at the assessment of neurosurgery examinations, which are written and are multiple choice. So this is for you to become a proper neurosurgeon. So you studied medicine, and now you want to get the license to poke in people's brains and treat them. So first of all, ChatGPT does not pass the exam because it has a higher pass rate than 50%. Typical pass rates are around 70%. And neuroanatomy and pharmacological questions, which are sort of questions of rote learning. What does this drug interact with? What is that bit of the brain called? Or if you go left from there, what do you find there in the brain? That it passes very well. But once you have to start thinking about complex judgments in planning settings, Amr set the exam and marked it in red, and I'm not going to go into the details. I think you need to be medically trained to appreciate that. But he could basically show how the system basically did not understand even the question right before answering that. And it made, of course, wrong suggestions. And people talk in this setting about hallucination, and that's a bad thing that generative AIs do. Now, if I were to sit that exam, I'm sure I could generate some text that looks reasonably sounding, but is definitely wrong. And that's because I can also hallucinate. In cognitive science, we call that confabulation. And we should be aware of that when we're saying, oh well, ChatGPT or our generative AI system does not always provide correct answers. In fact, the way it fails in the answers, it's the way many students fail in their exam questions. They make something up that looks good, and you still sometimes catch it. I think it's absolutely very human. It's a proof for me of the humanity of the system in some way, or of the reasoning. So this is just what I wanted to send ahead. I think, going back to the slightly more serious part, one of the things that I've been observing for the past 23 years, so in 2000, I was working for McKinsey in the business technology office as a consultant. And I learned about this Gartner hype curve. And that's a quite interesting thing to look at. So it basically says that technology follows a whole range of stages. There's an innovation trigger where some crazy professor comes up with an idea. Then there's, so to speak, a hype, the peak of inflated expectations. And then technology falls into the trough of disillusionment where it crashes and burns, like 3D TV. I think it came 3 times in my lifetime, and every time it failed. Some technologies make it up the slope of enlightenment, and then you reach the plateau of productivity. Now, if you observe this curve, and you can just go on Google and get the previous curves, you will see, so to speak, the whole range of human emerging technologies that comes across from science to technology, medicine, and engineering. And the interesting thing here is, first of all, foundation models. This is 2022, summer 2022, this was generated, so LLMs are at the peak of inflated expectations. But if you then go through the other stuff, like NFTs at that point were sort of already falling down, and now they're definitely dead. But what you're seeing here, if you just simply go through all these individual emerging technologies, 2/3 of these technologies are actually within artificial intelligence research. And if you go back 10 years, 15 years, AI or even computer science was maybe just 10 or 15% of these points. And I've never seen such a concentration of all human emergent technologies that humans are coming up with in such a narrow domain of AI. It's not computer science, it's AI, which is the subdomain of computer science if you think about it that way. And I think that's a very striking thing to be aware of. And it ultimately goes back to the reason about the ultimately fundamental revolution that machine learning brings about. It changes the way we innovate. Okay? So at this point, I wanted to talk briefly about the economics of things. And I'm not an economist, and I cannot really judge that. But I can read other people's statements on this. And I just wanted to give you a flavor where things are heading. So within machine learning, we're basically saying there are 3 flavors of machine learning. There's supervised learning, where you know the answer and you want the system to predict that answer. So I show you a picture of Mark, and you should say that's Mark Kennedy. Then there's unsupervised learning, where you need to find some form of structure in things, for example, for data visualization. And then there's reinforcement learning, where you need to find a policy, we need to find a way of finding a solution. So for example, you need a robot to be able to pick a banana, or a car to drive from here to Manchester without a car crash. And so supervised learning is typically embodied these days by classic deep learning architecture. I don't think I have to talk about it. I have a fantastic lecture from Minjin telling us about it. But one interesting point I wanted to add is that in neuroscience we found a whole lot of correlations of the representation that these deep neural networks have. And this is not about that they're neurons and synapses. It's about the different stages of representations in this neural network, from edges to parts of cars to entire cars, match the representations of the human visual pathway. Right? You stick electrodes in these different levels, and you will find neurons that encode very similar things to these deep neural networks. Now that's interesting, and then in 2018, McKinsey did a study, and I'm just picking that study randomly, to try to value what if we take all technology that can be replaced by deep learning in industry in the entire world, and they estimated that value to be around 0.8 trillion or $800 billion value to the global economy. And it's not about the absolute number, it's about the relationship between things. So that's supervised learning. Then we're coming to unsupervised learning, where you want to find structure in data. That can be, for example, in this data set at the top, the blue and the other dots, you want to sort of find some structure in there. Maybe they're two different groups because you want to segment your customers or your patients in some way. Maybe there's some underlying simplicity, this black curves that you want to discover. And then two examples of technologies that came out of unsupervised learning. So perhaps this point here, which was one of the most striking articles I read, that's Kofi Annan, the former head of the United Nations, saying, as an African, how using systematic data visualization to understand African nutritional data changed his view of Africa. And that's a person who was at the head of the global world government, if you want to call it like that. So somebody who definitely knew, and still using data-driven technologies that come out of data unsupervised learning, allowed him to transform his view of the continent that he knows intimately well. Another aspect of deep learning, of unsupervised learning, is of course being able to, from many examples of images, to generate new images, and even fake images. And so this is something that came out 2 months ago, where basically people use technologies like Stable Diffusion to generate, that's generative AI for you, generate images of politicians in certain settings. And again, you know, McKinsey tried to estimate that at the time. It's not so much about how powerful the technology is, it's about how much this technology impacts and what domains it impacts, at roughly $500 billion. So that's, you know, 30–40% less than supervised learning. And then we come to reinforcement learning, where reinforcement learning is ultimately about a technology that learns to act and interact, make many decisions in sequence. It can be steering a car through traffic from A to B, it can be getting a ship from A to B, or it can be playing a game of chess with you. There are many sequential decisions you need to make. And reinforcement learning is a technology that typically learns from interaction. So the algorithm makes an action, observes what's the impact on the environment, it then gets an update about what happened to the environment, and processes some reward. And this algorithm will try to maximize its long-term reward. And you train typically these algorithms interactively, and you have done that, and people have done that for quite a few years, for example, to optimize trading strategies. What shall I buy? How's the impact of that buy on the market? Was it a good decision? You can use that to train robots to perform warehouse operation. You can use that in auction pricing. It's actively used for balancing electricity grids. It's used for self-driving cars. And of course, in ChatGPT, it's part of something that we call reinforcement learning with human feedback. So these are the three basic flavors of machine learning. Now, the mind-blowing things about reinforcement learning or optimal decision-making is ultimately the power of agency, systems that can do things on their own. And so that value is estimated roughly at $5 trillion. Okay? Again, the numbers may change up or down. The point is, this is effectively 6 to 7 times the value that people attributed to just using deep learning to solve supervised learning prediction problems. That's how big agency is in a system. A system that can do things on their own and impacts all different domains of the economy. And that's why you then have predictions about the impact of generative AI on the UK economy or the global economy that are so striking with 30% growth rates in the near term. And then it becomes more interesting, because now we can try to understand how these three pillars are, and this is a very superficial review, so if you're a computer scientist like me, you're mildly annoyed, but this usually works for these type of talks that I give, to really give a flavor of what happens. When you combine ideas from unsupervised learning and supervised learning, you get effectively generative AIs, transformers. And because you have ideas about self-supervision, self-supervised learning, that sort of a mixture of unsupervised ideas to train supervised learning without having the answers. And so that gives you generative AI. And then when you're pairing up the transformers, the generative AIs, with reinforcement learning, then you can have truly interactive AIs that can be chatting to you. And that's the ChatGPT, Bard, and other systems. So let's just think for a second about what this reinforcement learning does here. It's something I care quite a bit about, and I think is a very interesting approach to think about also general AI. So, when I was young, I used to consume books by Isaac Asimov and other science fictions. And, in that days, it was very simple. So he generated a whole series of wonderful books where he basically said, there are 3 laws of robotics, and robots need to follow them. And the entire entertainment of the book was to see how you put humans and robots in difficult situations around these 3 laws and how they resolve them. Now, that's a classic view of intelligence, of AI even, that basically it's a clear interpretation of what you should be doing in these settings, and for all ambiguities, you need to read one of these books. But of course, you can't tell ChatGPT or another AI what you actually need to do there. And so here, a lot of development has been going on how to teach generative AI to act ethically. And so what you want to do is you want to make the AI learn human values and preferences. And of course, no 2 people in this room will perfectly align with these values. Now we sort of know it's not nice to kick a puppy, right? We can agree on that, but it can very quickly break down after that. You want to be able to oversee such systems at scale, that they're not doing something stupid when 100 million users are using them. You want the system to be honest. You want the system not to learn to basically tell you what you want it to hear, but you want the system to tell you the truth, or at least a good judgment. Now that's quite interesting, because the more we're looking at this, these are not new problems. These are problems as old as humans, laws, fairness, and morals. And of course it goes, we don't want AI to have some power-seeking or instrumental strategies. Now the interesting thing about large language models, they're based on text. And I don't know about you, but when I write a text, I always have a goal. Get a grant, convince people of my idea, or something else. And now you have a system that aggregates all these goals. What goals does the system have? And what's even more tricky, I can go to jail if I break the law. I can lose friendships if I abuse friendship. I feel bad when I do something bad. The AI doesn't care. It doesn't care if you switch it off. It doesn't care if you lock off its internet access. And all of these elements that we have don't exist in this system. So reinforcement learning with human feedback is a way to basically piggyback that knowledge onto that. And the idea is effectively, again, apologies for the very cartoonish view, is that you have a reinforcement learning algorithm that interacts with the human, and the human says, this was a good thing in my view. And it learns to appreciate what are good and bad things. It learns a value hierarchy. And then you can incorporate that with the LLM training that basically tries to imbue how these value judgments on the answers that an algorithm gives, an LLM gives, should be rated. What should be promoted, what should be demoted in their answers. And so this brings us to a very interesting stage where once you have learned these systems, you require actually a lot of data to make the system safe and usable. And we're talking here hundreds of thousands of tens of thousands of man-hours or person-hours where people sit and chat with the system and say, right, not right, and so forth. Now, if you're the parent of a child, that's literally what you do the first 10 to 18 years or 25 years of their life, telling them, giving them feedback, giving them value judgments. And I've not evaluated on my daughter the rate at which I need to do that, but it's not as bad. And again, it's a human quality of education, where we're passing on our values through sample examples. Okay? It's all very human somehow. It's because it has agency. It learns, it develops. And we should think about it like that and not like an artificial system. So this brings us to the point, what you want to have from a great large language model. Well, a bunch of things that you need to be able to see, and I think that need to be accounted for in the space of regulations. You want to have labels on the answers. Where did you get that bit of information from? Did you get that off a Twitter feed? Did you get that off an article in the New York Times? Where does this thing come from? So you want to know something about the provenance of the data at the large scale. You may want to have actual traceability. Can we work out which training entry points have basically driven your answer here? You want the system to be reproducible. I don't care whether the words sound exactly the same, but is it safe to drink chloro stuff, whatever, to remove COVID? I want basically the same answer, that it's not safe every single time, right? The problem is, a generative AI is generative, specifically ChatGPT, because there is a stochastic component that generates this variability. And this means if 99 million users get a yes, it's still possible that 1 million users to an obvious answer get a no, because it's a probability distribution. But we don't even know what the entropy, so the variability in the possible answer set is, even for binary questions. When these systems then are trained, one of my big worries was, Jesus, if this system is just exposed to advertisement, it's just going to learn, and it takes it for the naked truth. Not just, of course, propaganda is another thing, but just advertisement, which is sort of mild propaganda. How do you make such a system immune to that? And it's not clear to me that you can always prevent that. And I invite you to think about ways of testing whether certain product names are effectively placed in certain large language models because they've consumed certain amounts of advertising. So we need to think about the cost to enter new data, to cost to friction of new information being imbued in the system of what we call these days facts. Right? We want that feedback and argumentation. If I disagree with this system, or if I ask it to do something different, that just not changes your local chat history, that knowledge is used to update our reinforcement learning with human feedback parameters, that you want something different. This means we need to talk about personalization of such systems, which is not just your chat history, but it's also something that sticks with you in terms of changes to the model parameters. And we cannot talk about that without talking about privacy, and the good news is we have now privacy-preserving models to update these. Maybe we need to also think about business model, not based on engagement. So for example, Google Search finances itself by exposing you to advertisement. OpenAI actually uses a subscription model, and you just get the service for free. So we need to think about how we operate differently in this space if we do that. And I think just like in, for example, in the medical technology and pharmaceutical industry, where once you've developed a drug, you've approved it, you've shown people how you've checked for its safety. You've not given away your trade secrets, but you showed how you checked with it, you published the data. You need to go into the stage 4 trial, which is the pharmacovigilance. Does my drug do and keep doing that it works? With our COVID vaccines, that's still being actively done by Moderna, Pfizer, and all these people. We need to have a process for managing and onboarding any unforeseen impact of our technology. And so while people talk about, let's not regulate generative AI at all because it's like good open source. Linux will win if it's a good operating system and lose if it doesn't. On the other hand, people say, including the OpenAI people, let's go for treating it like nuclear weapons. I don't think that's the right approach. I think it's an approach that will close technological advancements to a lot of new companies that may want to come and to new initiatives that want to use these technologies. I think actually the best way to think about that is to think about it as a human agency technology. And that's like, we should think about it like we regulate, license, and certify medical doctors to be safe, allow them to learn, allow them to grow, and have processes in place that document it very similar to pharmaceutical and medical device research. Just the thought about these things. I've shown you some stuff. I've not shown you a lot of other stuff. And I want to come to an end because I wanted to take your questions. Just want to highlight that a lot of the work that we're doing has to do with generative AI, but we're not working on text. We're working on human behavior and we're working on medical data that is not necessarily textual, and that's the wonderful team that does the work in my lab.
Hello. Aldo, thank you very much for this talk. When you say about, what you're talking about here is the problem of alignment, right? Aligning our core values, aligning the AI to our core values. But how do we do that, assuming that we can regulate these things, when we might have completely different standards for values? Every single human being might have completely different morals, different ethical values. Assuming that we can pass some laws that regulate how we train them, blah, 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 how do we ensure, what is the best way forward, essentially, when we have such discrepancies amongst humans?
Okay, so at the moment, there's no law, right? So as a company, you just try to do it so as not to embarrass yourself. And then you embarrass yourself because the AI says something evil. And the point is, I think we should have standardized catalogs of questions. And I don't mean the specific question, the flavor of question, with which you, just like in a job interview, you find out, is this person crazy or actually, licensed to practice medicine and doesn't know their stuff. I think there are ways we can do that for humans, and I think in the same way we can apply this to these technologies. But what we need to agree upon is that there's that we make public what questions were asked, how the system passed these questions, right? We don't want, so to speak, secretive alignment, human interactions that we don't know who's this data from. Of course, if you recruit, 1,000 labelers in the Bay Area, you may get very different answers from somewhere else. And bear in mind, the Bay Area labelers are typically not the high-paid tech people, right? So you have very different value system coming in through there. So we need to make that public. We need to think about bias in the labelers as well. But all of this needs to be rendered public. Again, not the technology needs to be rendered public, but you need to tell us how you did the assessment. Just like for the vaccine that we all have, we were told how this was assessed, there were trials run, information was published, and it gave most of us certainty that this is a good thing to do.
Hello. I just have a quick question regarding reinforcement learning, if that's all right.
Sure.
What do you see as the main benefit of having human kind of in-the-loop feedback during the training versus, let's say, getting a batch of humans to manually annotate a set of data?
That's effectively the same thing. What the reinforcement learning with human feedback gives you is it automates the process and allows you to basically accumulate good and bad answer values, and it gives you what we call in machine learning a gradient that you can pass back into the system that the system can then optimize for. So it's a mechanism. It's a mechanism of interaction. Yeah?
Thanks.
But there's one interesting point, and that's something that I'm pursuing with a graduate student of mine, and that is the idea, well, we can do that online interactively, but maybe you have a book that you have read where the hero character embodies your values. Why can I not give this book to reinforcement learning with human feedback system and use the interactions in the book to train the system with the values that I want?
Hello, you talk about privacy and privacy-preserving models. How do you balance that with the need for, say, reproducibility, explainability, and the need to make models fair, unbiased, and ethical?
Very good question. Again, I think it depends on the application. If it's a medical system that gives you a treatment decision, probably you don't want it to be biased. But if you want to use a model as your friend, or someone that advises you on your political career or career move that you need to make in business, maybe you want something that is biased and thinks like you. Maybe you want it to be different from you. I think there are ways we can separate that, and also there are ways by which we can train a model with a general set and then basically learn the differences that make up the personalization. Yeah? It really depends how you're using this technology in the final application. Of course, in a medical setting, in a legal setting, you want it to be as unbiased and as standardized and systematic as possible. But we all don't have the same friend. We all have different friends and we choose them. So think about that like an AI friend.
Hello. Yeah. You just introduced another data term to me today, so data agency. Yeah, so, obviously you explained very nicely the importance of data to get a good AI, right? So having good data. How do we enforce that to the people who are building these AI applications, right? To get an honest AI, the fraud is increasing at the same rate at which the AI is increasing.
So there are three problems with honest AI. So the first one is we don't know what data is ingested, and we currently trust the people who are building these models. If you go for Bloom, the large language model by Hugging Face, you actually have a very open source documentation. You know where the data comes from. From other companies, you hear anecdotes that they digitized books but couldn't use them because they didn't have the okay of the publisher. And other companies, you have no knowledge what data was used, maybe because they themselves are not sure where the data was acceptable. So we need to talk about intellectual property and the meaning of that. The second problem is, once I have a generative AI, I can just make it generate text at ridiculous rates and just flood the internet with such information. How do we manage that? Well, that's the same problem as with advertisement. We need to think very carefully about how to curating that data. But again, that's a bit the same problem you have if you have a child and you expose it to the internet by giving it an iPhone, right? And you need to think about curation of that. And some people say this problem will solve itself because, bad text, boulevard journalism sort of is not convincing you, so you're not going to go for that model. And other people say, well, actually, we need to curate these models a lot more and have standards of good text, so to speak. Yeah?
Hello. This is yeah. Hi. So when you said I think AI would be like nuclear weapon, and I agree on that piece. And I see there are a lot of regulations also coming, like in Europe, European AI Act. AI Act is I think on the way, and there are some other acts are going geographic, regional wise, right? Like for example, Singapore and some good countries are quite advanced in AI Act. But given this, the AI, the product evolution is happening. That's happening quite globally, right? So how do you see like we should have one global regulation in place so that whatever will happen, I mean, it will actually come under that. Okay. And also one more question on that, like
let's start with one question.
Yeah.
Okay. So it's a very interesting problem. So 3 weeks ago, I was in San Francisco, where the World Economic Forum organized basically crisis meeting on that. And they had the heads of technology from the big companies, they had government people, intergovernmental people, and a bunch of professors there. And the interesting thing that arose there's some form of common agreement, but it's unclear that we will have a global regulation, because the question is where these AIs impinge on national sovereignty and national law. My hunch is it will evolve into the different major trade blocs, so the EU, the US, NAFTA, and the successor, and in the East Asian domain have slightly different or diverging regulations about how they look like. And they're already diverging in terms of privacy and data use, and I think we're going to see the same thing on the EU AI Act. Now, the EU AI Act has special provisions about AI autonomy and classes systems as based on risk, on what they're allowed to do in terms of agency. And the EU Act, as it is, it's not fit for ChatGPT and large language models. And I'm running on the 26th of June a meeting with EU advisors and EU legal people and researchers on exactly that topic. Because at the moment, the only solution that the EU has for dealing with the EU AI Act and ChatGPT's like systems is to systematically simply class them as very high-risk systems, and that basically prohibits them from many, many uses that would be, frankly, quite useful also within the EU. So if there's no adjustment, Europe will, so the European continent will fall systematically behind. And you've been using BARD here in the UK. Well, in the EU, Germany, France, you can't even log into BARD. It's simply not available because there is this legal uncertainty. And we are going to see some divergence there.
And the second question?
We'll save your second question, if you don't mind, for after the break, because we're going to have a panel with you, more further chance for a conversation. So let's go for a lucky last question.
Thanks, Mark. So Aldo, great talk. Sorry, it's me. Yeah, you know me. You know my voice. Come on. So things seem to be moving in the right direction for the big companies. My concern at the moment is for the open source stuff that's going on. where the models are actually being shrunk down dramatically. They're being combined together, so you get groups of agents that actually are fine-tuned to work in different ways. And these things are proving to be remarkably effective. What is going to happen at that end?
So I think that's a beautiful question. I think the question is, how are these open source efforts that are just beautifully documented, they may lack the scale of doing, hundreds, thousands of hours of human feedback reinforcement learning, but they have a lot of other benefits, and they show that smaller is not necessarily worse, that we will see these being used by academic, non-governmental organizations, maybe some nation states who want to, or conglomerates of nation states who want to build models that are basically based on this open model. And I'm sure also a lot of companies that want to enter this space, including, for example, law firms that are substantial in size but are not gigantuan in terms of funds. They may want to buy into the open models because they see what's happening in there. And actually, I'm not too concerned about the open source efforts if we keep the regulation at such a level that we don't make it impossibly expensive to do that. And I'm just saying you, certifying a nuclear power plant for operation is a whole different thing than certifying a new drug, right? And I prefer to have this technology in the drug domain. We vaccinated a substantial amount of humanity, so it's a global impact, but we have done this with a much more measured approach.
Okay, great. Will you join me in thanking Aldo, please? Fantastic. As you will have noticed from the agenda, we have a half-hour break now, whereupon we will come back and have a raw